Hi guys, so we are on to the fifth problem of this exercise. Let me just read it. All right. A 5 kilogram mass is on a ramp that is inclined at 30 degrees with the horizontal. A rope attached to the 5 kilogram block goes up to the ramp and over a pulley where it is attached to a 4.2 kilogram block that is hanging in mid-air. The coefficient of friction between the 5 kilogram block and the ramp is 0.10. What is the acceleration of the system? So we are going back to the Atwood's machine, but this is in relation to an inclined plane. So just make sure that you are still following the free body diagram. Okay, so let's just go. Let's start by drawing it. So we have the drawing. This is 30 degrees and this is okay. Sorry if it's not really straight or it's not really good to look at the drawing. It's really hard to control this. I hope that you understand. So this is 5 kilograms and this is 4.2 kilograms. So there you go. All right. So we've already had this a while ago. So this is the gravitational force, and you know that the gravitational force has the component for the x and y. So we make sure that we draw that. Let me just put this FG, and this is gonna be FGY, and this is gonna be FGX. This is the normal force, and this should be perpendicular to it. So let's just erase this. So this is this. Okay. For as long as you know that this is a straight line, normal force. So there you go. So first, we need to determine whether it's going on a clockwise direction or counterclockwise direction. Let's observe first the weight here, the gravitational force on 2 and the gravitational force on the mass 1. So this is mass 1 and this is mass 2. So let's observe. If you're going to observe, you will have the normal force of this one. It's going to be Fg1x is equal to m1g sine theta. I know that you already got the hang of it. This is sine theta because this is opposite. So you have 5 times 9.8 sine 30 is equal to 24.5 newtons. For this one, this is Fg2, which is this one. So this is going to be M2G, and M2G will be equal to 4.2 times 9.8. The answer for that will be equal to 41.2 newtons. All right, so you will observe that this one, Fg2, is greater than Fg1. So the system will accelerate in a clockwise direction. So this one will go up and this one will go down. So having said that, we can have the there is the coefficient of friction, so we need to consider that. So F is equal to mu Fn, which is also equal to mu mg cosine theta. Okay, because this is mg cosine theta. This is fgy. So you're considering this. All right. So we can have 0.10 times the mass is 5 times 9.8 cosine 30. The answer for that is 4.2 newtons. So the force of friction is 4.2 newtons. Now, what is the summation of the forces? So you have the summation of the forces, which is equal to, there are two different ways on how to deal with it. So I can have, so I know that the F is equal to FMA. This is F net. So A is equal to F net over the total mass. So I can have M2G minus M1G sine theta minus M1G cosine theta times mu all over M1 plus M2. So this is going to be equal to 41.2. Yeah, is it 41.2? Yes, 41.2 minus 24.5. This one. And minus 4.2. The summation is 9.2 of the masses. So the answer is 1.4 meters per second squared. So that's what you're looking for. So that's the acceleration.